Virtual Tour by APACOUC. Without any more delays, I would like to leave you with this amazing session by Lucas.
Thank you, Elsie. Thank you very much. Good morning, good afternoon, good evening, wherever you are, whenever you are. You might be watching this as a pre-recorded session. I'm going to quickly share my screen. There's a lot I want to share with you. And as I've mentioned on Twitter, this is probably my most personal presentation ever. It's about coding with honor. It's about the importance of our profession and the responsibility we ought to take and may not always be taking. Maybe you're different than I am. Since I understood from Kelsey that we're trying to get up the number of languages that are spoken during this event, I think I will just continue in Dutch. Dus de rest van deze presentatie zal in het Dutch. Just kidding. I understand that although some of you understand Dutch, probably not all of you do. So let's keep it to English. All right. Very brief introduction of myself. My name is Lucas Jellema. I'm CTO for Amis, which is part of Conclusion, an IT company in the Netherlands. And when I go to customers, I will be an architect, a solution architect, a cloud solution architect, or any other epithet that you can cling to the word architect, which is basically anything. I'm an Oracle Groundbreaker ambassador. I've been an Oracle ACE director since a long time ago. And here are some of the channels through which you can reach me, apart, of course, from the chat channel of this session. So as I said, it's a personal presentation. It's all about me. Well, not just me, it's me in the capacity of a software professional. And that begs the question, what even is a software professional? And I thought, well, a software professional is anyone who contributes to professional software. And of course, that doesn't really help things, because what's professional software? You probably think you know what software is, but what exactly makes it professional? And that's basically the core message of this presentation. What is professional software? So we as software professionals, we are not necessarily the hoodied gang that we are made out to be in films and series all over Netflix, and even my sons seem to have that impression, even though there are some nice hoodies. We're the cool, well, maybe not the cool gang, but we are at least proud craftsmen. We are professionals. Or are we? Whenever I speak to software professionals, people who program for a living, and I ask them about their professional pride, they will typically tell me they're proud of the solutions they've arrived at, the puzzles that they solved. And they're proud at their commitment and proud of their team and the way they're working together. But when I really prod them and ask them whether they're proud of the work they've delivered, of the software that their team produces, many of them pull faces. They're not necessarily all that proud of the outcome of all that hard work. And they will blame business for pressuring them, for demanding new functionality, never giving them the time to really do the work in the way it's supposed to be done. But I can't say that most software professionals are really proud of the work that they deliver. And it also applies to me. And that's a problem, of course. And that's a problem that we can solve too. And that's what this session is about. And I don't have a silver bullet for you, but there are many elements, and most of them you already know, and I already know. It's just a matter of taking them to heart and starting to apply them. So no silver bullet, but certainly elements that will help you, that will help me in becoming proud professional software developers. And of course, I've not been living under a rock. And we've gone through many changes and transitions in our industry. So for example, we went from waterfall to agile. And agile to me really means the introduction of the business, not just once every 6 months for a major release, but very frequently and very intimately, or at least that's the way it's supposed to be. And that's one of the key elements of Agile. And I also have known for a long time that the importance of software development, the initial software development, is not as great as I would like it to be. Maintenance of software is taking up far more of the cost than the initial development. Code is read more often than it is written. Something we should bear in mind. Something that we should apply when we are developing software to ensure that it can be maintained and to ensure that we can push down the maintenance costs so we can do more new development. New development typically means more functionality, more value for the business. And I've lived in this world where we had a wall, a fence, between the world of development and the world of production. And we've broken down that fence. But before it was broken down, we created software in development and we threw it over the fence, over the wall, whatever the expression is in English or in your native language. And then we sort of expected the guys on the other side of that wall to wave their wand, to sprinkle some magic dust and add to our software the things that we hadn't really paid too much attention to, such as scale, performance, security, stability, recoverability, and the ability to monitor our software in production. Of course, that has changed. The wall has been broken down. And I've always known, but not necessarily always taken to heart, that software does not have any value at all, unless it's running in production. So here, the vertical line indicates the go live date. Before the go live date, we are accruing cost, but we're not delivering any value. And we all know this. That doesn't mean that we've always pushed for early production as soon as to start delivering value as quickly as possible. It's something that I've become more and more aware of over time. Something, of course, I should always have been aware of, something that I always knew at least. So initially, there's no value. And the longer you wait before bringing anything to production, the longer it takes before any value is returned to the business. Probably the most recent transition, and another very important one, is where we have brought development and ops operations together. It's where we have tore down that wall, even later than the Berlin Wall, where we have one team that will build the software, do the development, that will run that software, operate the software, that takes care of the fixes, and that evolves the software through its life cycle, adding more functionality and also doing technical maintenance. That team owns the product. They really own it throughout its life cycle. And that too is extremely important and one to take to heart, not just to talk about, to actually live by. Talking about, I find I've been paying lip service, and it almost sounds like I've been a hired professional kisser. That's not the case, but I've paid lip service to a number of elements. I've talked about them, I've done them, I've asked my colleagues to do them, but to be honest, my heart wasn't really in them at all times. And I did these things because we were supposed to do them, certainly not always for the objectives that we were trying to achieve. And I've had sort of an awakening this last summer, and I'm not proud of it. When I talk about this as a personal talk, it's an emotional talk, and one of the emotions is shame. It's not the emotion I would like to be talking about. It's also the ambition to do better and to bring the rest of us along to do better, apart, of course, from the people who are already doing better that I can learn from. So here's a car. It's a beautiful car, isn't it? It's a beautiful car. One thing you should know about the car, the brake system of the car is powered by software. Another thing you should know about the car, about that software, that the software has about the same quality as the code that you committed last week, or that your colleague committed last week. That level of quality. Knowing that that's the case, would your mother-in-law get into that car? Or to try to make it funny, would you let your kids get into that car? The brakes are powered by software that have the same quality as the code that you committed last week, or your colleagues committed last week. Well, there are multiple options. Yes, of course, I would let my kids go in that car. Not sure. No. If the answer is no, then of course the question is, why not? What is your software good enough for then? If it's not good enough for letting your kids get into that car, is it only good enough for a demo, for a POC, for a prototype? Or is it perhaps good enough to go to acceptance test and hope that the people doing the acceptance test will find the bugs? Or, yeah, it's good enough. The quality of my software is good enough so that brakes will be safe and my kids can get into the car. Then the question is, how do you know? How do you know for sure what your software is doing and how it deals with all the situations real life can throw at it? How can you be so sure that your software is that good? What would you prefer? The following situation. You're an IT manager or business manager, and your team tells you we have no failing tests, or they tell you we have some failing tests. Well, maybe the second one is the better option, because the first one could mean that there are no tests at all. And here's my math mind speaking. If I have to pick one of these, 10% failing tests or 17.61% failing tests, I would go for the second one. The first one might mean we have 10 tests and one is failing. The second one seems to be a division of a fairly large number between an even much more larger number. So that feels better. More tests feels better. More ways to tell that the software is doing what it's supposed to do. So, as I said, it's about me as a software professional. This presentation, my ambition, and the message I'm trying to send to you. Is it about you as well? Are you a software professional? And do you want to be proud of the professional software that you create? Do you want to take your responsibility towards society? And those are big words, but I've been inspired. Maybe you're already proud and you create professional software and you can help me along. But I've been inspired by this guy, Robert C. Martin, also known as Uncle Bob. And over the summer, I was suffering from pretty serious back problems. And all I could do was watch movies, YouTube clips, and I was watching a presentation by Uncle Bob. And then I watched another presentation by him and another and yet another. And if you have time, you really should be looking at it as well. And maybe look at his presentation rather than mine. But unfortunately, you're at the moment looking at mine. Bob Martin had a room full of people. And he tried to determine with that room full of people how many devices they had on them and how much software was running on those devices and how many additional devices there were in the room that also had software in them, like the speakers and the air conditioning and many other facilities in the room. And then he went on to let them realize how important software has become in the real world. So not just the website of any web shop or an administrative system that's run once a month to produce a report that no one is going to read anyway. There's so much software all around us that most of our lives are affected by it in several ways. When it comes down to our health and safety on the one hand, like the brake system in the car, or even for our fun and daily comfort, that might not be so important, but of course that is in the long run also important in your life. There's so much dependency in society on the software that we create as software professionals. So we are entrusted by society with a lot of responsibility. And then he asked, are we, as an industry, are we that professional? Can we be entrusted? Do we even entrust ourselves? Do you send your kids into that car? And this hit me. This is where a nagging feeling that, to be honest, I've had for maybe most of my career started to become more explicit. And the shame set in as well. And fortunately, Uncle Bob didn't stop there. He then went on to explain what we can do to raise our game, to step up, to take that responsibility. And then he inspired me. And that inspiration led to this presentation and to many discussions with my colleagues about how we create software and how we can become better at that, how we can become professional software developers. So I was thinking about other professionals. My central heating guy, he came over sometime in the summer, which apparently is the best time to have your central heating fixed. And now we are in October and winter, or autumn, fall, winter is setting in. And I'm glad that he came along. And what do I expect from my central heating guy? My home comfort professional. Well, of course, I expect a functioning system. That's what he's there for. I get my heating and I get my shower water. And I get the water with the requested temperature, and I should get it fairly fast and in plenty of volume. Otherwise, I will have a problem with the rest of my family, and I wouldn't enjoy that myself. And I expect this to function within reasonable boundary conditions, from minus 20 degrees Celsius up until 30 degrees Celsius. Outside temperature, this should work. And of course, I expect whatever he delivers to be safe and to be according to any regulations, including all the ones I don't know about, because he's the professional and I'm not when it comes to central heating. And I expect that this installation will produce only limited noise and limited smells and limited gas consumption. So it shouldn't be too expensive to operate the system. And I expect the system to last for quite a while, at least 10 years, up to 20 years. It should be robust. It, of course, will have some wear and tear, but it should be limited. It should not be excessive. That's what the word means, of course. And I don't expect to see failures often. There might be a failure every now and again, but it should be easy to get the system running again, or it should at least be easy to have it fixed. And when there are small changes in the circumstances, inside the house, outside the house, slightly different composition of the natural gas that we're using for heating, or a small renovation in the house, then everything should, of course, still work. Maintenance, as I said, should not be needed too often and should not be too expensive. On a yearly basis, maybe 5% of the initial installation cost. And I don't want a very special system, something that's exotic. I want to have something that many people can work on, not just this one central heating guy. And I also want spare parts to be readily available from all around. I should not be tied to a specific vendor. Now, I'm assuming that you think all of this is reasonable, that this is something that I might expect from my central heating professional. If not, please let me know in the chat, and maybe there are some additional things that I would expect about his dress. But of course, that's not the important stuff. When you focus on these expectations, if you agree with me that these are reasonable expectations from a professional, then you could say it's about getting a functional system based on the specifications within the reasonable boundary conditions, safe and according to regulations, not too expensive to run. It should be robust and last a while. It should be adaptable, it should be maintainable, and it should not be very outlandish with very specific dependencies. And we expect any professional, so also my central heating guy, to offer suggestions and bring up anything to my attention that I'm, as a layman, are not aware of, that I should know before making a decision, before starting to operate my system. before starting to organize the maintenance schedule. Again, I'm assuming that you also think this is reasonable to expect from a professional. And now, and you may be dreading this moment, now we're going to turn the focus onto us. We are professionals too. So what are the expectations from this list that our customer would have from us, or that we would have from us if we were the customer? So my software guy, and in many cases, that's me, I also expect a functioning system. And I expect proof that the system is working according to specifications under all foreseeable, reasonable conditions. I expect that the system satisfies the non-functional requirements, such as performance, availability, and recovery of data and service if the system breaks down. I expect my system to be safe, to be secure, to be according to all legislation. I expect that the TCO, so the running cost of my software, is known and it's reasonable. It's not going to fluctuate wildly, and it's not going to be excessively expensive. I expect the system to last a while. I expect that with regular technical maintenance, I can evolve this system and bring it along with me for many years to come. I expect my software system to be adaptable to changes in functional and non-functional requirements, changes in the environment, small changes in the required functionality. The system should be adaptable in that way. The maintenance required for the system should not be required too often, and it should not be too expensive. And I don't need the super specialist to be flown in. I don't need a dependency. I don't want a dependency on very specific people, certainly not a single individual, or a very specific vendor. And of course, with my software guy too, with me, I expect the professional to offer suggestions and bring up any information that I should be aware of, but I'm not aware of because I'm a layman. So this is what we have to offer to the business. And again, my question to you, is this reasonable? Are these reasonable requirements? We as IT professionals, should we live up to all of these specifications, expectations? I think we should. I think this is not unreasonable. I'm not sure that I always live up to these expectations. I'm pretty sure that as an industry, we regularly do not live up to these applications. And again, that's a problem. It can be solved. So do most systems live up to these applications, to these expectations? Does your software? Does mine? I'm not going to answer for you. I know for the systems that I've been involved with, and there have been dozens over the years, many of them did not live up to all of these expectations. Some by only a small margin, some by a pretty big margin. Wasn't always the sole responsibility of the IT team, of course, but they were there. And they are the professionals. They should have stepped up. I should have stepped up. And again, that's where some of my shame comes from. And my resolution to do things better. So I made this resolution, and to be honest, I didn't make it right here at that moment, because this is a picture taken in Melbourne back in 2018 for the non-virtual APAC Groundbreakers Tour. I was there, I had a splendid time, and I'm not there. Now I'm in an attic in Zoetermeer in the Netherlands. And over the summer, I made this resolution. This resolution that I want to code with honor. I want to create professional software. And in my professionalism, I want to be proud. I want to take responsibility. I want to constantly hone my skills and my craftsmanship. I want to focus on the longevity of the software I create, unless it's very specific that the software doesn't require that. It's only meant until the US elections. Well, then we probably don't need to focus too much on robustness for a 10-year period. I want to be productive. I want to realize value, business value, and not just solve puzzles. I want to team up with all the people and stakeholders I'm working with. I want to step up. I don't want to do concessions to my professionalism. That is hard. When you start talking about this, and to be honest, when someone else would be talking about this to me, I would worry about being productive. I would be worried that any of this, no matter how important, would hurt productivity. And of course, that's not the case. There have been many studies. Let me give you two examples. There have been many studies that make it clear that productivity in the short run will suffer from focusing on professional software, on code quality, on all the expectations of IT professionals I just discussed. So that's until the dashed line. And after that point, high quality of code will actually help productivity. And I've seen that in action. Over the last year, I've been involved with a very interesting project, interesting in the good sense, not in the British sense. We have created an IoT platform. And as I said, we have been working on it for a year. And there's some software that's several months old that doesn't have the quality in every aspect that it should have. It doesn't have all the test sets. It doesn't have the clarity of code. And we are already suffering for it. We had it running very quickly. And now we're trying to evolve it. And it takes a long time, much longer than it should have taken. And again, that's my personal shame. And there are explanations. But let's return to the issue at hand. Productivity in the short term, that's in terms of weeks, will be somewhat less with this focus on quality, with this focus on professional software, with the demands that I will discuss later in this presentation. But after a few weeks, 4 weeks, 6 weeks, 8 weeks, depends on the size of the team, probably the complexity of the software, productivity will increase. And there's an even more rigorous study that's all about removing defects before software goes into production. The earlier defects are removed, the better it is. Of course, because those defects will not hurt production, will not bite into business value when it's too late or when it's real. But it also increases productivity. So with a focus on removing defects early on, the development time decreases. Again, probably not in the first few weeks of a project, but soon. So productivity is not at stake. In fact, productivity will be improved by focusing on creating professional software. And again, I'm still in the process of defining what that even is. So one of the biggest changes our industry has seen happened early in this century with the advent of agile software development. And as I said before, it means involvement of the business, which is very important. It also meant that teams started to operate as teams, which I really enjoyed. And I can't even imagine how we were working before, but I still remember. And I've seen teams where people were working on islands and didn't even bring their stuff together for weeks or maybe even months. But there's one thing in Agile that might be misguiding all of us, and that's this focus on working software. And even says working software is the primary measure of progress. And we have gone astray with the definition of working software. What exactly does that mean, working software? And it's putting the bar too low, we've discovered. So working software, well, you say it's working, but what work does it do? And how can you tell? So what exactly is it doing? Not the happy flow scenario or the thing that you can easily demonstrate and explain, but in total, the full scope of its functionality. What exactly is it? And how can you tell? How can you prove? And by trying to answer those questions, you're forcing us all to go from working software to professional software. And it takes more than just answering these questions, but it's definitely part of it. So we have to make this step from working software to professional software. And professional software is able software. And what do I mean by able? Well, it's all of this. Our software should be verifiable. You should be able to determine that it's doing what it's supposed to do in the way it's supposed to be implemented. And it should be operable, and the code should be readable, and the system should be evolvable and maintainable, observable and scalable and recoverable. And we should be able to prove that we've implemented functionally and non-functionally what we were supposed to implement. The system should be affordable. Of course, it needs to be deployable. We have to make it auditable, but also impenetrable. So again, professional software is able software. Doing what it's supposed to do is part of it, but there's certainly much more to it. And we might get into a debate about that's all fair and well, but what is that applying to? You say we have to create able software, professional software. What is software? And you could have a long debate, but the easy definition probably is any instruction that's executed by a machine. That's software. And there are many things that fall under this definition, and they should. And here's just, I do realize, of course, that there are different types of software. Some software is meant for demo or proof of concept, and we have different demands on that kind of software than on software that will be in production and that will run a nuclear facility, or that will become a reusable object that's reused across many different applications. There's also a distinction in where the software is used. Some software is used only during deployment or provisioning. So it's used to spin up a VM or to create a network. And other software is actually running at production time and will produce the value. And most of that software lives in the application layer, and most of the software that's primarily targeted at deployment provisioning time will live at the infrastructure and platform layer. So there are different types of code, and we will have distinctions in the way we test it, we manage it, we release it, and we monitor it, and how we respond to issues with it. But instructions that are executed by machines, and we don't typically write them as binary instructions, but of course, eventually they're all turned into what we could consider binary instructions. These are some of the things that then are software. Almost everything is code, is an instruction executed by a computer, like an Alexa command, although that's probably not on top of our minds. I would like to focus on infrastructure, because as you know, infrastructure is code these days. Anything is software defined, especially in the cloud. With code, you can specify your infrastructure and platform. And that code is just as much code as the code that presents a web page or executes a database query. And also in this tag cloud is the low code declarative application definition. Don't be fooled by the tag low code. Of course it's code. It's 4GL all over again. It's 4.3 GL perhaps, but it's declarative instructions that are executed by a computer. Well, first by a framework and then by a computer. It's code, and anything I said about able software and everything I'm going to say about what that entails applies to low code as well. And to most of the other things on this slide. Not sure about the instructions to your Roomba, but of course, in a way, that's code too. So I have an example, and I'm not going to name the company, but here's this company, and they have a number of tags applied to them, to the systems they're running. Their systems are old, they're not modern, they're custom built, bespoke software. They're critical to the business, they're legacy. And all of this actually should be good. Now, old isn't necessarily good, but it certainly isn't necessarily bad. I just turned 51. And legacy used to mean something positive. It's your heritage. A system we've known for 25 years, we've been able to hone, to polish, to know intimately, to make better over time. That's how it should be with legacy systems. We should be glad to be able to run our organization on legacy systems instead of having to build new ones all the time. But for some reason, we as software developers have let it slip and have turned legacy into a dirty word. So the things on this slide should not be bad, but they feel bad, which is a pity. The things that are bad are on the next slide. So the situation really is they're at the end of the physical scale of their systems. They can't scale up, they can't handle the load. They have extremely high technical debt. Systems have been around for 25 years, and they have, as I said, compiled a lot of technical debt. It's extremely hard to evolve the systems any further, to make any changes to the functionality, to satisfy any new business demands. They're very low on expertise, on the technology of the systems, but also on the applications themselves. And that, combined with the fact that they have almost no tests, no specifications, and hardly any trustworthy documentation, makes the situation even more dire. Their TCO is expensive compared to the value they're getting from the system. Of course, the system is critical to the business, so the value is extremely high. But still, at least they think their TCO is very expensive, and the system is fragile. They have many runtime issues. And when I showed this slide to a colleague of mine, he said, "Aren't you afraid that when this customer sees this slide, they will recognize themselves in it? And you're not supposed to talk about them?" And I said, well, chances are that they indeed will recognize themselves, as will dozens of other companies in the Netherlands alone, companies that I know of. Because this is a situation that many organizations will have. And we somehow let that happen. It's not all our fault as software professionals, but we are part of it. And we can help prevent this from happening again and from improving on this situation. Now, did this specific company or the dozens of other companies that are in a similar situation, did they ever make a decision to get there? Was it their intention to end up in this situation? No, of course not. Did they make any large decision that made it inevitable to go there? And of course, no, they didn't. It's the continuous sequence of small decisions to not implement a test, to not write the documentation, to not transfer knowledge from one person to another, to not spend time on creating code that was probably properly readable, to not implement the facilities for operations. All these small decisions, these small shortcuts, led to the continual erosion of the software. And that's what ended them up where they are now. And that's something that we let happen. As software professionals, we allow the business to allow us to make the shortcuts or to force us to make those shortcuts. That's where we should have stepped up and have to step up in the future. So once again, working software. We have to go from working software to professional software. I may have mentioned that before. So the working software goes to professional code or professional software. Those are two steps, two stages in the software lifecycle. And on this slide, I'm not going to try to describe a process, although there are some process elements. I'm trying to describe the quality levels any software will go through. But before we even get to working software, we need, of course, to have specifications. And specifications can come in the form of very loosely worded description, the typical user story, that's not good enough. To get to professional software, we need our specifications to be professional as well. And we need these specifications to be expressed in behavior tests. So we are able to prove that we live up to the specifications. We don't have such rigorous behavior tests, but we don't really know whether we've implemented the specification. And of course, by creating these tests, we force ourselves and our business representative to come up with a complete specification and a proper specification, not just a loosely worded user story. So with the definition of ready, when we meet the definition of ready in the specification, only then can we create software that at some point we can call working software. And working software does what it's supposed to do, but not necessarily is implemented in the way professional software should be implemented. So we take the next step to go to professional code. And then with the definition of almost done, we can hand the professional code to the team, and the team will accept it. And then we produce built software that has been compiled and combined with all its dependencies into an artifact. And this artifact is deployable. And once we have deployable software, we satisfy the definition of done, and the team is done. Only when we have deployable software can we really say as a team, we are done. Of course, it's not deployed then, because deployment, that's a decision of the business, not something that we as a team can decide. So our done does not depend on the decision to deploy. Of course, hopefully, deployment to production follows quickly after our done. Ideally, it's even continuous deployment of all the software that we have delivered. And then we are running in production live software that's under ops, under operations, and that's professional and able. And there is a next stage too, of course. At some point, our software will be riding off into the sunset, will be retired. It's a step many organizations have not really implemented all that well. Hence, they have running dozens, maybe even hundreds of applications that are still there, and no one really knows the value. And we as consultants come in and do application portfolio scans, and we try to determine of all these applications what the actual value is, if they should still be there, and if so, who even owns it and who is using it. And that's not the topic for today's presentation, by the way. So these are the stages. And with each stage, we have toll gates, we have rules and guidelines that we should satisfy. And we have tools to enforce these rules and guidelines. And we have tools to help us realize the implementation that satisfies the rules. So working software, we could define it as it's according to the functional specifications, and all the technical interfaces are doing what they are supposed to do, and we can prove it. And we have proven it. And if we haven't, it's not yet working software. It's software that does something, that compiles and runs under certain circumstances. So working software is not the loose definition that in many cases it has become. So this behavior test I was talking about, it tests the required behavior as experienced from the outside. This is what we also call the acceptance test, but we tend to organize the acceptance test way later in the process, and I'm talking process after all. The behavior test is something that we can derive directly from the functional specification. Or even we could write the functional specification as a behavior test. So a behavior test might be a specification. It describes the expected behavior from the outside of the system. It doesn't talk about internals. The system is a black box. And how it's implemented is up to the software professionals. But the behavior tester, the acceptance tester, the tester on behalf of the business, is interested in that required behavior. And that test, as I said, it specifies the behavior, it documents the behavior, and it also verifies the behavior. These tests can be run, ideally fully automated, in a fully automated fashion, by anyone, so also by the software developer when he or she is developing the software, to verify whether he's living up to all the behavior, the expected behavior aspects. And then there's the unit test. And the unit test is ours, it's not the business's. We use the unit test for ourselves to also verify behavior, but then we are focusing on the technical APIs and interfaces. We are focusing on all the elements in the code that we want to be able to reuse. And we probably will focus on the verification of behavior of the complex algorithms, the things that are hard to understand by looking at the code, or the things that are so important that we need to verify their behavior in their own right. And the things we are looking at are, of course, functionality, but also non-functionality, like performance. We are looking at happy flows, but we most certainly are also looking at non-happy flows. And in a unit test, we try to eliminate the number of dependencies of the element we are testing. We call this glass box testing or white box testing. We are fully aware when we create these tests of how the implementation has been done. And we may even fiddle with the implementation to make testing easier, to make our software testable. That's one of the abilities of professional software, that it's testable. And of course, that it's tested as well. And test is so much more than I've always thought it was. This is one of the major findings for myself. And again, I apologize and I feel ashamed. Some of the major findings for myself over the last summer, how important tests are, not just as proof of working. And of course, that's very important, but there's so much more. A test is also the functional contract. The test lays down the specification of the required behavior and is thereby also the documentation of that behavior. If I want to know what code is doing, I can try to look at the code and try to understand the code, but it should be much easier to look at the test. If the test covers all the required functionality, then the test will tell me what the system does, especially the behavior test, of course, but the unit test will help as well. The test also helps the developer. When the test is there, the test and running the test provides a very quick, I always forget what REPL stands for. It's loop, it's print, it's evaluate, and it's the very quick creation of code, running of code, and evaluating the result of running the code. And the test is a perfect harness for doing that very rapidly. The test is also an insulator, a line of defense, an extremely important element that allows us to refactor code, to optimize our code, to apply technical upgrades, because all the while, the tests should still succeed. And if we have a fully test-covered code base, we can work on that code base and use the tests to prove to ourselves that we are still doing the right thing. And if one test fails, we probably have to undo one change in the code and we can continue, refactor, optimize, and upgrade. The test also, of course, is our regression detector. It helps us detect whether a change we've made has undone the required behavior, has compromised the required behavior. But very importantly, the tests also help us find out, and this is not the unit test, by the way, this is the integration test, to help us find out if something was impacted by a change made somewhere else. So you make a change in your component, and all of a sudden my component doesn't satisfy its tests. It's something that probably should not happen, but it will happen, and now at least we learn about it. Tests are very, very important to detect regression. And tests are also used as health indicator. I'm not sure why PowerPoint gave me a cigarette for a health indicator, but probably because of the word smoke. So a health indicator and a smoke detector. We use tests right after deployment and also continuously in our production environment, any environment, to detect whether things may have been broken by anything really, by any change at the infrastructure level, the platform level, in the world, the internet broke down, our data center was hit by lightning, we don't know what happened, but our test will find out for us. and help us respond quickly. So tests are part of operations as well as of the development. And then finally, test is also a reference for using code. If I want to find out how to reuse a package created by a colleague, I can just look at the unit tests. And by the way, that is probably the easiest way of starting to use a third-party library that you get from somewhere on GitHub. You can look at the tutorial, you can look at the documentation, but best you look at the unit tests that are shipped with that library. Tests are incredibly important. One of the key things to take away from this talk. Excuse me. So some things that we should worry about around tests, and here is a very impressive Latin quote. Who watches the watchman? So we have to determine who creates the tests and when are they created. And we have a tendency to create tests after the fact. One of my team members said the other day in a stand-up, I'm done with this story. I'm only now working on creating the tests. And to be honest, I was a little bit horrified. There's quite a bit wrong with that statement. The tests are part of the task. So suggesting that the task is done except for the tests sends completely wrong message, especially with an eager product owner who might be tempted to say, well, then since it's done, you can move on to the next task. The test will never be created, and we have created more technical debt. We have started the erosion of the system before it's even built. It's also, of course, the wrong order. A test should be created preferably before creating the software, or at least at the same time as creating the software. It should not be created after the fact. The behavior test, or acceptance test, but I prefer that term, behavior test, ideally that's created as soon as the specification is available, or even as an expression of the specification. It should not be created long after we have implemented the code, because our code can only be considered done if it satisfies the behavior test. And we don't want to have to wait for some acceptance tester to appear and perform the acceptance test or the behavior test. We want to be able to do that automatically. So I think the behavior test, and it's not something that I've come up with, should be created at the same time probably as the software is created by different person, different responsibility, different head, but it should be available to the developer before the end of the implementation phase. Otherwise, well, it couldn't be ended. So in that sense, it's always available before the end, if the end only comes when it's available. Sorry. With tests, of course, we need to make sure that we have proper coverage. And there are two types of coverage. The first one, specification coverage. Well, actually, there are multiple types of coverage. Specification coverage. Have we covered in our tests all the specifications for a system? And of course, code coverage. That's more well known, better known. Do our tests at least cover all the lines of code in our system? If they don't, either we have code that's not tested, therefore cannot be trusted. Well, that's certainly the case, and that might be code that's never invoked anyway. That's dead code, and that should also be taken out of the system as soon as possible. Of course, simply having a high degree of code coverage doesn't really mean anything. It's easy to create tests that invoke all the public methods, but don't really test anything, don't test any behavior. So code coverage by itself doesn't mean much. We also need to have condition coverage. Do our tests cover the full range of conditions that we will throw at our system, or that our users will throw at our system? Sorry, just kidding. We also need to make sure that the tests are actually executed. It's a good thing to have those tests, but if we don't execute them as often as we should, they're still not very meaningful. So tests are very important, and making sure that the tests satisfy certain requirements is very important too. But before we can start implementation, the story, the task description needs to be ready. And you know, in Agile, we have this definition of ready. And in this definition of ready, and that again is one of the major milestones in the life cycle of a specification, the functional specifications should be clear, unambiguous, and fully understood. It's easily said, and most people will agree, it's not easily achieved or verified. And we tend to overlook the various boundary conditions, the non-happy cases, anything that's exceptional, so that the specifications very often are not really ready. And we only discover this as we are implementing a story, or even after that fact. So more focus on the definition of ready and forcing that a story is ready, or accepting that the creation of the specification to get it ready is an iterative process, which requires the involvement of someone representing the business. That's another way of doing it, but it is very important. And also the non-functional requirements are clear. And ideally, of course, now I'm living in a dream world, the business value of the feature is also defined. We know why we are doing something, we know what it's worth. And that, of course, helps us determine what the TCO budget is. How much may the implementation cost to run, to operate? That's a pretty high bar. But clarity of specifications, completeness of specifications, and all the boundary conditions covered in there as well, that's something we should expect, we should enforce. That's where we have to step up to make sure that we understand all of this before we even start the implementation, or at least before we complete the implementation. That's on us to ask for it, not on us to provide it, of course. You may be familiar with the test pyramid. Recently, there has been a bit of a shift to what's called a test trophy. Different types of tests performed at different levels and at different moments in time, although with all the automation, these moments in time come together very, very rapidly. We have the static tests, or the code analysis, code quality, the unit tests that test elements on their own and using mocking to provide the dependencies, the integration tests, which exclude external systems but look at all the internal components linked together, and the end-to-end tests that really take everything together. And then there's this cherry on top of all of that, and that's the live test, the smoke test, that not only looks at all of this in an acceptance environment, but also in a production environment, right after deployment, and as far as I'm concerned, continuously throughout the day, every day. And there is a shift in the thinking about testing from focus on unit tests to more focus on integration tests. And part of it is that unit tests with mocked dependencies are hard to create. There's a lot of effort there. It doesn't spark joy. And of course, our lives should be sparked with joy. And also because there can easily be created additional problems in the mocking code, which itself is not tested. So the test may not even be all that reliable. And the unit should function in its integrated environment. And if the tests can run quickly enough, and we only test the things that have changed and can easily rely on dependencies, if they are available, then the integration test probably is to be preferred over heavily mocked unit tests. It's a shift, and I'm not really part of the discussion. I'm listening to the discussion. Seems to make sense to me. So focus on integration tests above unit tests. And then there's additional treasure chest that goes along with testing. Treasure test, and test would be the abbreviation of that. Oh, never mind. What's in the treasure chest? That's the test data. To be able to conduct our testing quickly, consistently across environments, is extremely important that we have a proper test data set. And it takes a lot of time for developers to create these sets. So properly creating them and managing them and making them available in every environment, including production environment, is hugely beneficial, to say the least. So here are the various types of tests that are described in this test trophy. On the left side, we have tests in isolation, more isolation. On the right, we have tests with less isolation. There are many other things that we could say about these tests. As I said, we are seeing a shift from the fully isolated, fully mocked unit tests to more sociably wired unit tests or integration tests. At the bottom, there's also the chaos test. That's interesting. That's for the advanced organizations. That's where we deliberately introduce issues with our platform and infrastructure components to verify our recoverability mechanisms. It should never impact our users, but it forces us to ensure that our facilities are working okay. So that's monitoring, that's automatic response, failover, recoverability. That's beyond the scope of this presentation. So one of the things Bob Martin also said when we talk about applications is that it all starts with the business logic. That's the heart of the application. That's where the functional specification is truly implemented. And of course, this business logic typically requires persistence, but it's only because there is a specific requirement to persist data. It doesn't start with persistence, it starts with the business logic, which is the translation of the required functionality. But yeah, persistence probably is required. And we probably have to deal with external systems that we interact with. It all starts with the business logic, but yeah, there are external systems to deal with as well. And our business logic is probably going to be exposed. And it's exposed through an API or a public interface. So the external world can interact with the business logic that's at the heart of our system. And external systems could make use of this API, this public interface, our web service. And yeah, of course, there probably is, in many cases, a front end as well. And here's probably the importance of this slide. We tend to consider the user interface the same thing as the application. But in fact, the user interface is only a wrapper around the application or the top layer of the application. So we should not focus all our attention on that front end. And we should try to explain to the business that it's not just about the front end and that the front end is even easily replaceable, or we could have multiple front ends, but that the real essence of the application is in the business logic. And this should be reflected, of course, in the way we test. We should not only test at the front end, and even the behavior test should not only be at the front end. And external systems could come to the front end as well. So when we talk about testing, there should be unit testing at all the programmatic interfaces. And even if there is not a public programmatic interface, we probably will require unit tests or integration tests, as I was just describing. And we want to have behavior tests, not just at the front end, but also at the public API. They are black boxes, so we don't have to go to internal interfaces, but they should be at these two levels. Smoke test, the health check, is only at what's really perceived from the outside, could also be at the public API, by the way. So the foundation of the testing trophy is static. It's the code quality analysis. And what are we looking at this stage? And there are great tools to do this for you that you have to configure, of course, but that will run code analysis all the time. And some of the things that we're looking at, well, most importantly, is the code implemented according to standards? That's not the whole story for professional code, for clean code, but is it implemented according to all the standards that we have adopted as a team or as an organization? And some of the elements that we will be looking at through those standards, but additionally as well, is have we implemented code in a consistent way? Is the code readable and therefore maintainable? Don't we have code smells? Things that are well known to occur in programs that are funny, that are probably mistakes, that are easily confused, and that should be replaced with better implementations. We also try to limit the complexity of the individual code elements, the functions, the methods, the classes. If it's complex, we IT professionals, we humans cannot handle it. We don't handle complexity very well. So we want to limit the complexity. We want to create maybe not simple things. Well, yeah, we would like to create simple things. Our code analysis checks on the code coverage of our tests. It also verifies the vulnerability of all of our dependencies. That's all the third-party libraries that we import into our application. That's a lot of code that we don't control, but we do depend on. Are there vulnerabilities, known vulnerabilities in all these dependent libraries? Extremely important. Code analysis tools have the ability to automatically apply improvements as well, like linting, for example, for formatting the code. Here's another metaphor, another car metaphor. We have this great car. I like the color, I like the shininess, and I've been told that it also drives very well. So it's a working car. And here, of course, starts the metaphor. If you look under the hood of the car, what we might encounter, well, what we see is the implementation, at least the implementation of the engine and things connected to the engine. It's what makes the car work, but it could look like this. And it's a working car, but under the hood, it's a mess. And it's, of course, not maintainable at all. So a working car should be taken to the level of a professionally working car, if you like. Of course, I'm stretching the metaphor here. And under the hood of a professionally working car, we would find something like this. It should look very organized, very well maintainable, very readable. And refactoring is what gets us there. Although it would be a hard refactoring process to get from the mess under the hood in the lower left-hand corner to the professional implementation on the upper right-hand corner. So refactoring is something that a developer does to get his working software or her working software to become professional code, to satisfy the definition of almost done. And while the software professional is refactoring, he or she is using the unit tests, the QA tool, the behavior tests to make sure that the code still is doing everything it's supposed to do in an increasingly good way, or at least with an increasingly good implementation. So refactoring takes the code to compliance with all the standards, to reduce complexity. Well, I've mentioned these things before. And also to ensure that the code is operable, that it produces the proper logging, the logging that can be used to monitor and to act and to analyze. Logging is very important. Don't really have the time today to discuss logging, but it's very important. And also to produce metrics, to have the proper configuration settings that allow us to configure the code during deployment, maybe even after deployment, as to not have to go into the code to change hard-coded variables. And also in refactoring to take care of lifecycle management, to switch to new versions of libraries, if that is what we have decided. And also to pay off some of the technical debt, or if that's required, to explicitly take on more technical debt. That might happen, that's life. And in order to do this, in order to do refactoring, we need a local build pipeline, a local runtime environment in which we can run the code that we are working on, and to very quickly and very frequently, because it's so quick and so easy, to do the full code analysis, to perform pull and merge from the master, and to perform an automated build and test. And then refactoring becomes fun. I was in a session at Devox last November by Victor Rendea, and he did a live refactoring demonstration, and it was awesome. If you have a chance, and I probably should add the URL to the presentation or to the chat, that's really inspiring. And what we get to is what's also called clean code. Clean code is typically the term used by Uncle Bob Martin. I've used professional code, but it's almost the same thing. Clean code is code that you read with joy. It's like well-written prose. It's code that has very little what the F's, or am I allowed to say what the fucks? Well, at least it's code that doesn't surprise you. It's code that with each next line, you will encounter what you expect to see, more or less. And extremely important in code is naming. Naming of variables, naming of functions. And not as important as I thought it was is code comments. Code comments are really the poor man's solution. If your code can't speak for itself, then you add a comment. But of course, it's better if the code can speak for itself. Here's an example, very simple example of what refactoring could do. Here you see code, and it works. It lives up to the specification. The unit test succeeds, but it's horrible code, of course. It's very hard to understand what's going on here. And now I'll show you the equivalent code. Well, this is code to cry over. Here's the equivalent code in the sense that it does the same thing. But of course, this is much more readable, understandable, and therefore evolvable. And we don't really have time to go into the details of the code, and that's not all that interesting. But the comment is lying. Here's a code comment, and of course I made this comment lie, so it's my fault, but the comment is lying. It said discard check for temp workers. That's complete rubbish. Maybe at some point this code handled that task, but no longer. So that comment is lying, and payroll.distribute check is probably telling the truth, because that's the code that's executed. Just as a simple example on how important refactoring can be and how important naming things properly can be. And any book, any presentation on refactoring will discuss naming probably as its most important topic. So a team, and here I'm blocking the essence of this picture. We work in teams, and I hugely enjoy working in teams. But there are some comments that I frequently hear that make me realize that working as a team, working together, getting coffee for each other, sharing your personal life's details, sharing your virus contagions, that's not the only thing that makes you a team, or it's not the whole truth, if you like. Earlier this week, one of my colleagues said, and there's a literal quote, this old code, and it's less than a year old, is hard to maintain because the person who built it has left the team. And that's a bad thing, of course. Not necessarily if the person left the team, because that happens all the time, but the fact that it's hard to maintain because it sort of depends on that person. That code was never adopted truly by the full team. And then as a team, we're working in parallel, but we're not really working together. And that is very important to get over with. And maybe this next slide is the most important slide, maybe not this slide, but the story that goes with this slide. It's about metamorphosis. It's the miracle of the PR. And PR turns out to stand for 3 different things that are very closely linked together. This is where our code, our individual code, becomes professional code, but also becomes owned by the team. It's no longer my code, it's the code of the whole team. This is crucial. So the PR stands for pull request. I think I'm done with the code. I think my code is professional code. Please do a peer review. And the pull request, that's a technical action through which we try to get to merge the code from our development branch to the trunk, we trigger a pull request that will result in a peer review, and when that's done, we've achieved production readiness. 3 times PR. PR could also stand for please review. Please, here's my code. I'm offering it to the team. Please accept my code. And I will show you, and you want me to show what the code does and how it's implemented. And I hope you will appreciate my work. Please look at it. Give some attention to what I've been doing, and then help me improve it, and help me to improve myself, to become a better developer, and take co-ownership of this code. It's your code now too. That's what the peer review should be about. And the peer review can complete only when the code is able and the code is beautiful in the eyes of the beholder, and the beholder is the peer. And when the code has been merged from the branch to the trunk. And at this point, the tram may roll in. And this is something that probably doesn't mean a thing to you, but this Dutch expression, it's a bit cynical. Please check in your code before you go home, because you might be hit by a tram. It's a Dutch way of saying, ensure that anything you're doing doesn't depend on you, because you might be hit by a tram. There are so many nicer ways of saying this. You might go on vacation, you might find a better job, you might win the lottery, but we say you might be hit by a tram. So the peer review, as I said, is very important, and give priority to the peer review. Don't try to do it in your 5 minutes break. Doing a proper peer review, and you should be doing proper peer reviews, takes real commitment and substantial time. To do a proper peer review of a piece of code that someone has been working on for 4 or 5 days is not done in 15 minutes. It takes much longer, much longer, and it's worth it in every way. Do I sound angry? I'm almost angry. So once we've done the peer review, we have professional code, we can automatically take the professional code to be built software, and then our software is on its way to the launching pad. And when it's deployable software, it's at the launching pad, and I keep getting in the way. I'm at the launching pad. I'm not at the launching pad. I was at the launching pad. Now my software is at the launching pad. It's deployable. It's not yet deployed because that's up to the business. And with continuous CI, continuous integration and continuous delivery, we have this full process up to deployability. And when we have continuous deployment, we also automatically roll out when it's done. But that's really up to the business to deploy the software, and we get it from done, from deployable to live. And now it's generating business value. And ideally, of course, the time between the peer review and the launch of the code is very short. But that's not up to us. That's a business decision. It should be fully automated, no human touch required or even allowed. And there should be a smoke test immediately after deployment. I've mentioned that before. And of course, all operations should be activated before or at least at the moment of deployment. And then you probably know what's coming. This lovely little bird, the canary. The canary was used in the coal mine to detect dangerous gases, because the canary would fall over, die, and hence be a signal to the mine workers. We can't test everything. We can even deliberately decide to not test some things, but just roll out the code to a live audience, to production, and then, like the canary, start watching for signs that things may be off, and then respond very quickly. That's the idea of a canary release, first release to an audience that can handle it, that's friendly, or just for features that aren't hugely critical, we can just roll them out and see what happens. Of course, it'll take a lot of canaries that we will be going through, but what we have is a process, and we have to very closely observe the canary, the life signs of the canary. But what we have is a process, a fix forward process, that's not a special procedure to create a fix. We do a tiered rollout to 1% of the users, to 10% of the users, and we watch and we spot an issue. And if there is an issue, we can very quickly assign priority, define the test to reproduce and to guard against regression, create a fix on a branch, just like we would implement any feature on a branch, go through a peer review, a pull request, and a merge to the trunk. It's done. The business can decide to roll it out, and we can very quickly fix issues in the same process that we're using for implementing new features. And then we have professional software, and it's generating value for the business. And it can keep on generating value for all time to come. Or can it? Because time is our friend, time is on our side, time will heal all wounds, but time also erodes. And we have seen that before. Software will wear down. You would think, well, it doesn't have any mechanical strain, so how could it be worn down? And here are some examples on the slides of things that could be in mint condition, but are still outdated, are still worn down. The thing with the ropes, that's the quipu. Interesting story from the Incas. Don't have time for it right now. So we need to implement life cycle management. We need to have technical maintenance to counter the effects of time. And there are many triggers that should prompt us to perform a technical change. And we need budget, we need to convince the business, otherwise we will end up in a situation that I described for the customer case. So we have to proactively monitor as a DevOps team, and here are some of the triggers that should prompt us to apply technical change, or at least consider making technical changes. I don't have time to go through the list, please do it in your own time. The mere progression of time is also part of this. One thing I probably should add here is that tracking the actual usage made of features in your application can be hugely beneficial, so you know which features can be gotten rid of. You don't want to spend time on upgrading or even migrating features that are not used at all. And yet that's happening all around us. For another day. So we've seen what time can do, and we have to counter that, and technical maintenance is what we should do. Lifecycle management of our technical stack and technical maintenance to counter the effects of time. Now, very briefly, I will mention some tools, but this list is not exhaustive, and I'm not even saying that all the tools are the best tools for the job. One is without discussion, source code control is essential. You need a tool, and Git is the tool to use. It used to be Subversion, it used to be CVS, now it's Git, and there's really no way around this. And then there are tools for testing that you should consider, tools for various types of testing, tools for code quality, tools for building, tools for organizing automating the whole build process, tools for checking on vulnerability, tools for recording the artifacts that come out of the build process, tools for rolling out those artifacts, and tools for monitoring while we are live. But I'm not going to go into tools. There are so many tools, and we really have no time, and you have to make your own tool selection. So I'm coming to the end of the presentation, and I said before, code with honor. That's my ambition. It's my resolution. I will work on this so I can be proud. I can be I shouldn't probably say a proud boy. That's not PC. We can be proud professionals, not just me, but also me. And we can make sure that we want our kids to get into that car. All our software has that quality, or at least has the required quality. And we produce able software, and we have all these tests to prove it, but also to document it and to be able to do refactoring. We take our working software and we take it to the level of professional code, and we make sure it's team owned. We go to the PRs of pull request, peer review, production ready. We do our technical maintenance, and in doing all of that, you will regain both fun and purpose, and that makes your professional life more worthwhile. Thank you for your attention. I hope this was useful. I hope you have a great day, and I hope we'll meet again. Thank you very much.
Cool. Thank you. Thank you so much.